The next one we're going to talk about is the soil flap method. And this is a lot like the soil wrap, but it is where the soil flap does not necessarily need to be tucked in. I don't need to wear my belt. It's for slope backfill material, and it provides erosion control protection, basically. It also provides, like the toilet paper, it provides reinforcement into your slope. So on this one, as you build your lift up and you build your layer up, you roll your rolled erosion control product out and you just flap it down. Now, if most of it is under the embankment, or half of it's on the embankment, half of it's down, you don't have to worry about anchoring the top part of it. It's anchored very well. Build your next lift, flap it back down. The constructability, this one is entirely constructible. It's so fast. In fact, almost every slope that uses erosion control blanket should be built this way if you're building a fill slope. Come up, flap it, come up, roll your blanket, flap it, and so on. And then what you need to worry about or concern with is after you flap it down, this part you have to anchor into the soil. So choosing your anchor would be very important. But there's no sense spending more on an anchor than you would spend than the longevity of the product you're going to be using. There's no sense going in there with a duckbill anchor that's going to last 20 years when the fabric's going to be gone in 2. Okay, so benefits. This technique provides the resistive forces necessary to hold the soil in place. It does not require wrapping the backfill, so it's less labor intensive. The slope is stabilized and protected as the embankment fill is constructed. So immediately as you build it up, you've protected it. And it also promotes, as all the RECPs, you promote vegetation establishment. Some limitations, it may be cost prohibitive, although you're just paying for the blanket. The labor is next to nothing if you were going to install blankets anyway. You must do this during construction. You can't retrofit it. You can't go back after. It would be part of your design. It's unsuitable for embankments or slopes steeper than 1.5 to 1. There's not a lot of reinforcement going on. And also, where wouldn't it be appropriate? On a hydrologic soil groups A and B, which would be susceptible to a lot of seepage, especially those A and B slopes that are steeper than the angle of repose. And then when you're specifying the 900 grams for establishing vegetation may be difficult because, again, that material is so dense that sunlight energy becomes a slightly limiting factor. Okay, so coordinate with geotechnical design unit when proposing this technique. You can use it with things like topsoil, duff, erosion control blankets, brush layering, and all the other standard SSPs. Let's take a look at the drawing on the back, and hopefully you can see it's very much like the soil wrapping, your final product, except it's not wrapped around on the bottom. Okay, we covered flaps. Let me give you a couple examples here. When we first did it up on Buckhorn, we used cheapo erosion control blankets that were left over on the job. Sound familiar? And rain on snow events tore the material, and there was just as much erosion until we got up in here when we actually specified the coir netting, and then the stuff held together. This is one where we did an RECP flap up on Buckhorn. We built a slope. We used compost. We learned in our first class, we taught you that if we put UC Davis study, we put 25% compost mixed with native soils, we were able to get 1 3/4 infiltration rates, an hour infiltration rates, rooting depth of 4 feet in 1 year, and by adding that material, and not compacting it. So we rebuilt this cut slope. There was our study down there, UC Davis study. We rebuilt this slope back up. We built it in 4 days. As we came up, we kept it at optimum moisture and tractor packed it. We took a nuclear densiometer on it. They said we didn't have to reach compaction, but what did we get? Well, in fact, we got 92% just by having optimum moisture. We didn't compact the face. We flapped it. You see, we built up our next lift. We put some brush layering in, flapped it. And this site withstood that first big winter. I think we got 65 inches of rain that first winter, and everything grew great.